Hi guys, so we are done with the trig unit and now we are moving on to circles. Circles is kind of a longer unit, it has a lot going on. There's a lot of different theorems that we're going to learn. But for this first section, we're going to keep it really simple and just do an introduction to circles and talk about some of the basic vocab and some of the basic formulas like for radius, diameter, and circumference. All right, here we go. So first I have the definition, the mathematical definition of a circle. I mean, I'm sure you probably all know what a circle is. You can identify a circle, obviously. But mathematical definition is the set of all points that are a given distance from a given point. And so what we mean by that is, say you have your given point, and it's the set of all points that are a given distance from that point. So let's say all the points are that far away. So together, all those points would make your circle. So that's the formal definition of a circle. Obviously, that wasn't the greatest picture, but that's okay. All right. The next thing is the center. That is that center point where it says like from a given point. The center is just the middle of the circle. We name the circle using the center point. So the symbol for a circle is just a circle with a little dot in the middle. Oops, that's not in the middle. Let's make that a little bit better. Oh, okay, not much better. That's okay. So that's the symbol for circle. Now, if we're going to name a circle, just to give you an example, if you take a look at this one down here, that one would be called circle R. And so when you're naming it, you can write the word circle or you can use the symbol. So if I'm going to use the symbol, it's circle R would be how you would notate it. Okay, here are a few definitions. A radius, a lot of you have probably heard of a radius before. A radius is a segment with one endpoint at the center of the circle and the other endpoint on the circle. It's basically like the halfway point. It's a segment that represents halfway of a circle, half of a circle. A chord is a segment with both endpoints on the circle. And a diameter is a specific type of chord that goes through the center of the circle. One thing to mention is a lot of you probably know the relationship between a radius and a diameter, but a diameter is equal to twice the radius. So that's something that we will use a lot. Okay, so I'm just going to do a couple quick examples in this picture down here. If we are going to name this circle, I already did that up above, but you would either write the word circle and say capital R, or we could do the symbol for circle and a capital R. Either way, it's a capital R because it's a point, so we want to make sure you use the right notation. Okay, name the radii. So there are actually 4 radii. Radii is the plural of radius. The 4 radii here are these 1, 2, 3, 4. They come from the center and they go to the edge. So one endpoint is at the center, one is on the circle. So that's the definition of a radius. Okay, so let's name them. We have AR. Remember when we're notating segments, you do capital letters with the bar on top. So we have AR, we have XR, we have RY, and we have BR. Now notice the order that I did them in. It doesn't really matter, but notice like for some of them I put the R first. The R second. In this one I did the R first. It doesn't matter. The order doesn't matter with the segment, as long as you have 2 capital letters with the bar on top. Okay, next one is chord. A chord by definition is a segment with both endpoints on the circle. So like AX would be a chord, YB would be a chord because both endpoints are on the circle. This is also a chord, YX, because both endpoints are on the circle, and AB, also a chord, both endpoints on the circle. Okay, so to list the 4 chords, we have AX, we have YB, AB, and YX. Okay, so that's the chords of the circle. A diameter, by definition, is a chord that goes through the center. So if you look at the chords that we just listed, the only ones that went through the center are AB, and XY. So those are considered diameters. Notice that the diameter is 2 radii. So this is a radius and this is a radius. Together it makes a diameter. Okay, so let's list the 2 diameters. We have AR. So, okay, so let's list the 2 diameters. We have AB and XY. Those are the diameters in the circle. Okay, the next part says if AB is 18, so this whole thing is 18, which is a diameter, find AR. So AR is a radius. It's just going to be half. So we're going to do 18 divided by 2, which is 9 millimeters. Okay, next one. If RY is 10 inches, so let's take a look back at the picture. This is 10. Find AR and RB. So RY, that's a radius. AR is another radius. And so all radii are congruent in a circle because it's always the distance from the center to the edge. So that'll always be the same. So these are all 10. So then if we want AB is the whole thing, double the radius, which is 20. So AR is 10 inches and AB, the diameter, is 20 inches. Okay, so that's some basic circle vocab. The last thing we're going to talk about in this section with intro to circles is circumference. So circumference is like the perimeter of, say, a rectangle. It's the distance around it. Since, like say for a rectangle, if I asked you to find the perimeter, you just add all the sides. Well, a circumference is one big side and it's curved. So there is no add the sides. It has a specific formula. So one of them is C equals 2 pi r. The other one is C equals diameter times pi. Now, when I say the other one, they're essentially the same formula because 2 times the radius is the same as the diameter. So it's really the same thing. It's just your preference as to which one you want to use. I'd say I mostly use this one. But yeah, I kind of go back and forth. It kind of depends on like what you're given in a scenario. So either way, that's how you find circumference. Okay, so this example on the back says, find the circumference of a circle with a radius of 6.8 centimeters. So first I'm going to find the diameter just to show you. A lot of times the questions ask for the diameter and the radius. So diameter is just going to be 2 times 6.8, which is 13.6 centimeters. And so now for the circumference, you can either do 2 times pi times 6.8, or you can just do 13.6 times pi. Either way, it's approximately, when you do it in the calculator, 42.73 centimeters would be the circumference for this example. Okay, so that's just very straightforward. Number 3 asks us to find the radius and the diameter, and we're given the circumference. So this one we have to kind of work backwards. So think about circumference equals diameter times pi. And if I know the circumference is 40, I can plug in 40 for the circumference, and I can solve for d. So this is multiplication here. So if I want to get the d all by itself, I can divide both sides by pi. Remember, pi is just a number. It's approximately 3.14. You do not want to type 3.14 in your calculator. All calculators, whether it's scientific or like a phone calculator, if you turn it on the side, should always have a pi button. So this diameter here is approximately 12.73 inches. And it's also asking for the radius. So I'm just going to cut that in half to get the radius. So the radius here would be about 6.37 inches. Okay, so that's how you can work with the radius, diameter, and circumference. The very last thing we're going to do is something called find the exact circumference. So just real quick, I didn't really leave room up there to define it, but exact circumference, if we're going to come down here, basically what we mean by, and if I ask you for the exact circumference, we don't want to put it in the calculator. So basically up here, notice on example 2, this was an approximation right here. We rounded. So exact circumferences, we want it in terms of pi is what it's called. And so that just means that your answer will have a pi symbol in it. You're not going to ever multiply it through. So for exact circumference, you can say leave answer in terms of pi. And we can also say that we don't want decimals. So your answer should not have a decimal anywhere for exact circumference. Sometimes your answer may even have like a radical in it, and that's okay. But you're never putting anything in the calculator for exact circumference. Okay, so let's go up and do this one. So if we want circumference here, in order to get circumference, we need the diameter. So pretty much for all these exact circumference problems, you have to find the diameter. And so if you look at this first one, this diameter here we'll call D. This is a right triangle. And actually, it's an even more specific type. It's a special right triangle. It's a 45, 45, 90. So remember, like to hypotenuse for 45, 45, 90, you multiply by radical 2. So the diameter here would be 9 radical 2. So now for your answer, we literally just put 9 radical 2 times pi. But the way that you should just write it a little bit better is the pi goes next to the 9. So if you started off like this, 9 radical 2 times pi, I put the pi in between the 9 and the radical. That way it's, you don't accidentally like put it underneath like that. So this would be your answer, and then you would just label units, inches. Okay, so that's the first one. Let's do another one. So as you can see, this one, they're not always going to be special right triangles. Like this is just a regular, oh dear, I don't know what just happened. Okay, this is just like a normal right triangle. It's not special. So we can use Pythagorean theorem here. So we can do 8 squared plus 6 squared equals d squared. So it's going to be 64 plus 36 equals d squared, which if you add that, that's 100. And then lastly, take the square root. So we get the diameter is 10 centimeters. So the exact circumference here would just be 10 pi centimeters. And that's your answer. So that's it. So actually, let me just add in a little example here. Let's say that your diameter, let's say you did Pythagorean theorem. Let me just make something up. Hold on. Move this down. So let's say you have a circle and let's pretend that's in the middle. We have a right triangle. And let's say it was like 3 and 7. I don't know. I'm just making this up. So you'd have 7 squared plus 3 squared equals d squared. So that'd be 49 plus 9 equals d squared. 49 plus 9 is 58. And so you take the square root, and you don't want to get the decimal for that. So that last one you just did worked out nicely because it was a perfect square. But if it's not a perfect square, you would just leave it. So like for this one, we would say that it's pi radical 58 would be the answer. Units, whatever it is. So I just wanted to show one like that, just in case it does come up in the future. You just leave the radical as is. All right, so that's it for Intro to Circles. Let me know if you have any questions.